Tonight, we're talking about light years, and to understand them, you have to realize something strange. Every time light touches you, you're feeling the past. Imagine standing on a beach at sunset, the sun warming your face in real time. But that light is already 8 minutes old by the time it reaches you. Light moves at about 300,000 kilometers per second, fast enough to circle Earth more than 7 times in a single second. And yet, even at that impossible speed, space is so vast that light still takes time to cross it. That's why distance in the universe isn't just distance. It's time. So, light is fast. We've established that. The fastest thing in the universe, moving at 300,000 kilometers every single second, never stopping, never slowing down. And yet, let me tell you about our neighbor. The nearest star to our sun is called Proxima Centauri. It has a nice name, doesn't it? Proxima means nearest or next to in Latin. The Romans used it to describe things that were close by, right next door. So how far away is our closest neighbor? 4.24 light years. Now, we just talked about light years. We know what that means. It means if you could travel at light speed, that impossible speed that lets you circle Earth 7 times in 1 second, you would need 4.24 years to reach Proxima Centauri. 4 years. At light speed, to reach the nearest star, let that sink in for a moment. Picture yourself at 20 years old. Graduation, maybe, full of plans and energy. You get on a spaceship that can somehow travel at the speed of light, which, remember, is impossible. But let's pretend. You leave Earth heading for Proxima Centauri. You travel for 4 years. The entire time, you're moving at 300,000 kilometers per second, circling Earth 7 times every second. The fastest anything can possibly go. When you finally arrive at Proxima Centauri, you're still 20 years old, because at light speed, time does weird things for you. But when you turn around and come back to Earth, another 4 years of travel, everyone you left behind is now 28. You've been gone for 8 years of their time. Your friends have graduated, started careers, maybe gotten married. They've lived 8 years of life. And you're still 20, but you've just spent 8 years traveling to the closest star and back. And that's at light speed. Let's talk about real speeds. Human speeds. The fastest spacecraft we've ever built is the Parker Solar Probe. It's designed to study the sun, and at its fastest, it reaches about 190 kilometers per second. That's incredibly fast by human standards. It's the fastest object humans have ever created. At that speed, it would take about 7,000 years to reach Proxima Centauri. 7,000 years. The ancient Egyptians built the pyramids about 4,500 years ago. If they had launched the Parker Solar Probe toward Proxima Centauri back then, it would still be traveling. It would be more than halfway there by now, but still not arrived. And when it finally did arrive, in about 2,500 more years, every civilization that launched it would be dust. Every language would have changed. Everything would be different. Or let's try something even more relatable. Let's say you get on a commercial airplane, nice, comfortable seat, flight attendants bringing you drinks. The plane flies at about 900 kilometers per hour. You're heading for Proxima Centauri. How long would that flight take? 5 million years. Not a typo. 5 million years of continuous flight. You would need about 200,000 generations of pilots to complete the journey. When you launched, humans were barely humans. We were still figuring out how to use stone tools. And when you finally arrived, assuming humans even still existed, they would be unrecognizable. This is what I mean when I say even light is too slow for space. The nearest star, our closest neighbor, the star with nearest literally in its name, is so far away that nothing we can build could reach it in a human lifetime, or in 100 human lifetimes, or in 1,000. Space isn't just big. It's so big that big doesn't describe it. It's hostile to the very concept of nearness. Let me take you on a journey. Close your eyes and imagine you're a photon of light. a tiny particle of light leaving Earth right now. You launch from Earth, and immediately you're moving. 300,000 kilometers every second. You pass the Moon in just over 1 second. The Moon, which took Apollo astronauts 3 days to reach, you pass in a blink. 8 minutes later, you pass the Sunday, our enormous, massive sun. The center of everything we know is behind you now. You keep going, hours pass. You're moving so fast that Earth's entire orbit around the sun would blur into a thin circle if you could see it. But you're still inside our solar system, still in our neighborhood. 5.5 hours after you left Earth, you pass Pluto, the edge of the planets, the place where most maps of the solar system end. You've traveled for half a day at light speed, and you're just now leaving the planetary region. But you're not done, not even close. You keep traveling, days pass, weeks, months. The sun behind you gets dimmer and dimmer until it's just another star in the darkness. You're in the space between stars now. The void. There's nothing out here. No planets, no asteroids, no dust. Just emptiness stretching in every direction. 1 year passes. You've traveled 1 light year. You're still not even a quarter of the way to Proxima Centauri. 2 years. 3 years. The emptiness is absolute. There's nothing to mark your progress. Nothing to see. Just darkness and the faint glow of distant stars that never seem to get closer. Finally, after 4 full years of traveling at light speed, you arrive at Proxima Centauri. You look back toward Earth. Our sun is just a bright dot in the darkness. The solar system, the planets, everything you know, compressed into a point of light, too small to show any detail. And you realize something. The space between stars isn't space between anything. The emptiness is the main character. Stars are just tiny decorations scattered through an ocean of nothing. In 1977, NASA launched 2 spacecraft called Voyager 1 and Voyager 2. Their mission was to explore the outer planets, Jupiter, Saturn, Uranus, Neptune. They did that beautifully, sending back stunning images. But they kept going. They're still going. Voyager 1 is now the most distant human-made object in space. It's traveled for over 45 years. It's about 23 billion kilometers from Earth. That sounds incredibly far, right? It's traveled 0.002 light years. After 45 years of continuous travel, it's covered 0.002 of 1 light year. At its current speed, it would take about 70,000 more years to reach Proxima Centauri. If it was even headed in that direction, which it's not, space swallows distance. It consumes it. It makes our fastest speeds look like standing still. And here's what makes this truly unsettling. Space isn't just empty between stars. It's actively growing. The universe is expanding. The space itself is stretching, which means that distant objects are moving away from us, not because they're traveling through space, but because space itself is growing between us. But we'll get to that later. For now, just sit with this. The nearest star is 4 light years away, 4 years at a speed nothing can reach, 70,000 years at the speeds we can actually achieve. And between us and that star, nothing. Absolute nothing. A void so empty and so vast that your brain has no framework for understanding it. You think of stars as being scattered through space, but it's more accurate to say space is occasionally interrupted by stars. The emptiness isn't the space between things. The emptiness is space, and stars are rare, tiny, impossibly distant exceptions to the rule of nothing. When you look up at the night sky and see thousands of stars, you're not seeing them as they are. You're seeing them as they were years ago, decades ago, centuries ago. Each point of light is a message from the past, traveling through the void to reach your eye. And every one of those lights, every single star you can see with your naked eye, is part of our own galaxy, our neighborhood. We haven't even left home yet, and already, the distances are breaking our ability to comprehend them. So if this is just our neighborhood, just the nearby stars in our own galaxy, What happens when we zoom out? What happens when we try to see our whole galaxy at once? The Milky Way, our galaxy, home to somewhere between 200 and 400 billion stars. We can't count them exactly. There are too many, and many are hidden behind dust and gas. But 2 to 400 billion is the estimate. Try to picture that number, 400 billion. If you counted one star per second, without sleeping, without stopping, it would take you over 12,000 years to count them all. And how big is this collection of hundreds of billions of stars? 100,000 light years across, 100,000 years at light speed to cross it. Let that number settle for a moment. We just talked about how 4 light years to the nearest star is an almost incomprehensible distance. Now multiply that by 25,000. That's the width of our galaxy. The light you see from stars on the far side of the Milky Way? It started its journey 100,000 years ago, before humans left Africa, before we were even fully us, when our ancestors were just beginning to walk upright, just starting to use fire. Those photons of light were already traveling through space toward Earth. Think about that. Light has been traveling for longer than human civilization has existed, for longer than agriculture, longer than written language, longer than any city or empire. That light was already ancient when the pyramids were built, and it's just now reaching us. When you look across the galaxy, you're not seeing space, you're seeing time. You're seeing the past, deep past, past so distant that it predates everything we think of as human history. In the 1920s, an astronomer named Harlow Shapley was trying to figure out where our solar system sat within the Milky Way. For a long time, people assumed we were at the center, because, well, why wouldn't we be? Everything seems to revolve around us, right? But Shapley studied globular clusters, these dense balls of old stars that orbit around the galaxy. He measured their distances and positions, and he realized something humbling. We're not at the center, not even close. We're out in the suburbs, about 2/3 of the way from the center to the edge, just another star in a spiral arm, in an unremarkable position. The galaxy has a center, and it's a busy place, dense with stars, filled with activity, and at the very core, there's a supermassive black hole with a mass of about 4 million suns, but we're nowhere near it. We're out in the quieter regions, where stars are more spread out, where things are calmer. And maybe that's good, because near the center, stars are packed so closely together that their light would fill the sky. Night wouldn't really exist, and the radiation from all that stellar activity might make life difficult. Out here in the suburbs, we have darkness, we have space between stars, we have room to exist quietly. Our sun takes about 230 million years to complete one orbit around the galactic center. Think about that. 1 year for us is one trip around the Sunday. 1 galactic year, one trip of the sun around the galaxy, is 230 million Earth years. The last time we were in this position in our orbit, dinosaurs had just started to appear on Earth. The next time we complete this position, if humans still exist, we will be something else entirely, something we can't even imagine. Now, imagine you could somehow walk across the galaxy. You're a giant, able to step from star to star. You start on Earth. In our solar system, you begin walking toward the far edge of the Milky Way. You walk at a normal pace, 5 kilometers per hour, just a steady walk. How long would it take you? 23 billion years. The universe itself is only about 14 billion years old. You would need to walk for longer than the universe has existed to cross our galaxy on foot. And remember, you're walking from star to star, but the stars aren't close together. Even at our imaginary giant size, stepping from star to star, there's mostly nothing between them. Mostly emptiness. Your feet would fall through the void more often than they'd land on anything solid. The Milky Way looks like a bright band across the night sky if you're somewhere dark enough to see it. It looks solid, like a river of light, but it's not solid at all. It's an illusion. Those stars, those billions of stars, are so spread out that the galaxy is mostly empty space. If you were somehow transported to a random location within the Milky Way, the chances are overwhelming that you'd be in empty space, far from any star, surrounded by darkness in every direction. Space is big, we keep saying that, but it's hard to really internalize what that means. Here's another way to think about it. If you shrunk the sun down to the size of a grain of sand, just a tiny speck, then Earth would be a microscopic dot about 3 centimeters away, invisible to your naked eye. The solar system, including all the planets out to Neptune, would fit in a circle about 1 meter wide. Still sounds manageable, right? But Proxima Centauri, the nearest star, would be another grain of sand 7 kilometers away. 7 kilometers. If you placed 1 grain of sand down, then walked 7 kilometers, about an hour and a half of walking, you'd place the second grain of sand. That's the distance between stars, even at this shrunken scale. And the Milky Way? At this scale where stars are grains of sand, the galaxy would be over 20 million kilometers across. The distance from Earth to the Moon is about 380,000 kilometers. The Milky Way, with stars as grains of sand, would stretch over 50 times farther than the Earth-Moon distance. Space isn't just big. It's incomprehensibly, brain-breakingly big. And the Milky Way is just one galaxy, one collection of stars, one island of light in a much larger darkness. But even as we talk about these impossible distances, something strange is happening. We're getting used to them. 4 light years to the nearest star? That felt shocking at first. Now 100,000 light years across the galaxy? It's just a bigger number. Your brain is starting to go numb to the scale, and that's dangerous, because we're about to zoom out again. And when we do, you're going to feel that shock all over again. That sense of the bottom dropping out. Because the Milky Way, vast as it is small, it's tiny, it's nothing. There's a neighbor, another galaxy. You can see it with your naked eye on a clear, dark night. It's called Andromeda. It's similar to the Milky Way, a spiral galaxy with hundreds of billions of stars. It's our closest large galactic neighbor, and it's 2.5 million light years away. Remember, 100,000 light years across our galaxy felt huge, incomprehensible. Now multiply that by 25. That's the distance to Andromeda. Light from Andromeda, traveling at 300,000 kilometers per second, takes 2.5 million years to reach us. When you look at Andromeda in the night sky, you're seeing it as it was when our ancestors were barely walking upright, when they were just starting to make the simplest stone tools, when they were, in almost every meaningful way, not yet human. All of human evolution, from those primitive tool users to you, sitting here, listening to this, all of that happened in the time it took light to travel from Andromeda to Earth. And here's the thing that should make you feel something strange and unsettling. We're not seeing Andromeda as it is now. We're seeing Andromeda as it was 2.5 million years ago. It might look completely different now. Stars might have died. New ones might have been born. The whole structure might have changed. But we won't know for another 2.5 million years. We're looking at a ghost, a memory, a photograph frozen in time by the speed of light. And this is true for everything we see in space. The farther away something is, the older the image we're seeing. We're not looking at the universe as it is. We're looking at the universe as it was, layer upon layer of past, stacked on top of each other, all reaching us at different times because they started their journeys at different distances. Astronomy is time travel. Every telescope is a time machine. We're seeing the history of the universe play out in light, each photon a messenger from the past. And if the Milky Way felt big, if the distance to Andromeda felt impossible, we're only just beginning, because there are more galaxies, billions of them, some so far away that their light has been traveling toward us since the universe was young. How far can we see? How deep into time can we look? In 1995, astronomers did something that seemed insane. They pointed the Hubble Space Telescope at a tiny patch of empty sky, not at a known star or galaxy, just at darkness, a spot so small it would be covered by a grain of sand held at arm's length. Some people thought it was a waste. Why point our most powerful telescope at nothing? Why waste precious observing time on empty space? But they did it anyway. They pointed Hubble at this tiny dark patch and left it there. For 10 days, Hubble stared at nothing, collecting every photon of light it could, and then they developed the image. In that tiny patch of empty sky, they found almost 10,000 galaxies. 10,000 galaxies, in a space smaller than a grain of sand at arm's length, each galaxy containing billions or even hundreds of billions of stars. Each star potentially having planets. All of it invisible to the naked eye. All of it hidden in what we thought was empty darkness. This image is called the Hubble Deep Field, and it changed how we see the universe. Because if this one tiny random patch contains 10,000 galaxies, then the entire sky, if we could see it all with the same clarity, would contain billions upon billions of galaxies. The universe isn't just big. It's so full, so densely packed with galaxies, that empty space doesn't really exist. Point anywhere in the sky, look deep enough, and you'll find light. Ancient light. Light from galaxies so far away that their photons have been traveling toward us for billions of years. Look at the Hubble Deep Field image, and you're looking at time. The closest galaxies in that image are a few billion light years away. Their light started traveling before Earth even existed, before our solar system formed, before the sun ignited. That light was already ancient when the first bacteria appeared on Earth. The farthest galaxies in that image, their light has been traveling for over 13 billion years. The universe itself is only about 13.8 billion years old. We're seeing these galaxies as they were just a few 100 million years after the Big Bang. We're seeing them when they were young, when they were just forming, when the universe itself was still an infant. And here's what should break your brain. Those galaxies might not exist anymore, not in the form we see. 13 billion years have passed since that light left. Stars have been born and died. Galaxies have collided and merged. Everything has changed. But we won't know how they look now for another 13 billion years. By the time that light reaches us, if humans still exist, we'll be something unrecognizable. We live in a universe of ghosts. Everything we see in the night sky is the past. The farther away it is, the deeper into the past we're looking, and most of what we see is gone, changed, transformed. We're surrounded by light from things that no longer exist the way we see them. Now, let's talk about distance. How far away are these galaxies in the Hubble Deep Field? Some are 13 billion light years away, right? Because their light took 13 billion years to reach us? Actually, no. It's weirder than that. The universe is expanding, space itself is growing, stretching, and it's been stretching the whole time that light was traveling toward us. So those galaxies, which were maybe 13 billion light years away when they emitted the light we see, are now much farther. In fact, the observable universe, the sphere of space we can see around us, is about 93 billion light years across. Wait, how is that possible? The universe is only 13.8 billion years old. Light has only had 13.8 billion years to travel. Shouldn't the observable universe be only about 28 billion light years across? 13.8 billion in each direction from us. This is where your brain starts to hurt. And it should. Because the universe doesn't follow the rules. You think it does. While light was traveling toward us, space itself was expanding. The galaxies that emitted that light were moving away from us, not because they were traveling through space, but because space itself was growing between us. It's like running on a treadmill that's also stretching. You're moving forward, but the treadmill is getting longer behind you. So the distance between where you started and where you are keeps growing even though you're running. Those distant galaxies, the ones whose light took 13 billion years to reach us, they're now about 46 billion light years away. They've been receding from us the whole time, pushed away by the expansion of space itself. This means the observable universe, the sphere of everything we could possibly see, is about 93 billion light-years across, but we can only see light that's had time to reach us. And since the universe is only 13.8 billion years old, we can only see things whose light has been traveling for 13.8 billion years or less. There are parts of the universe we can never see, not because they don't exist, but because their light hasn't had time to reach us yet. And in some cases, it never will, because space is expanding, and the farther away something is, the faster it's receding from us. There are galaxies receding so fast that their light will never reach us, ever. No matter how long we wait, the universe has an edge, not a physical edge, but an observational one, a boundary beyond which we cannot see, because light from beyond that boundary hasn't reached us yet and maybe never will. We live in a bubble, a sphere of visibility. Beyond that sphere, the universe continues. Probably. We think, but we can't see it. We can't ever see it. It's beyond our cosmic horizon, and that should make you feel something. Because we're trapped, not by walls or barriers, but by distance and time. We can never know what's beyond our bubble. We can never see the whole universe. We're stuck in our little sphere of visibility, able to see only a fraction of everything that exists. And even within our bubble, almost everything is out of reach. Andromeda, our nearest large neighbor at 2.5 million light-years away? That's close. That's practically touching us in cosmic terms. And it's still impossibly far. At current technology, we couldn't reach it in a million human lifetimes. The galaxies in the Hubble Deep Field, billions of light-years away, we could never reach them. Not even in theory. Even if we could travel at light speed, which we can't, it would take billions of years. And by the time we got there, everything would have changed. Those galaxies would have aged billions of years while we were traveling. We'd arrive at a place that no longer resembles what we saw when we left. You're sitting in a universe where almost everything you can see is unreachable. A museum you can observe but never touch. A history you can read but never visit. In 2003 and 2004, Hubble did it again. They pointed at another patch of empty sky, even smaller than before. This time in the southern hemisphere. They called it the Hubble Ultra Deep Field. Same result. Thousands upon thousands of galaxies. Every direction you look, if you look deep enough, galaxies. Billions of them. Each one containing billions of stars. Each star potentially having planets. And all of it so far away that the light took billions of years to get here. There's a galaxy in that image that's 13.2 billion light-years away. Its light has been traveling toward us for almost the entire age of the universe. We're seeing it as it was when it was young, when it was still forming, when the universe itself was barely out of its infancy. What does it look like now? We have no idea. We won't know for another 13 billion years. And by then, if humans exist, they won't be human anymore. They'll be something else. Something evolved beyond recognition. This is what light years mean. Not just distance, not just time, but separation, isolation, an unbridgeable gap between here and there, between now and then. When you look at the night sky, you're seeing a history book. Each star, each galaxy, a chapter from the past. The nearest chapters are recent, the farther chapters, billions of years old, and you're reading them all at once, layers of time stacked on top of each other, all present simultaneously, because light travels and space is vast. You're surrounded by ghosts, ancient light from ancient sources. Some of those sources are gone now, stars that burned out, galaxies that collided and merged. The universe is constantly changing, but the light from the past keeps arriving, keeps showing us what was, not what is. And this is the strangest part, the most unsettling part. There's no now in space. Not really. When we say the universe as it is now, we're lying. We can never see the universe as it is now. We can only see the universe as it was. Each point of light showing us a different moment in the past. The farther away it is, the older the past. The universe you see is a patchwork of different times. Recent past nearby, ancient past far away, all of it arriving at your eye simultaneously, but none of it showing you the present. Time and distance have collapsed into the same thing. 1 light year of distance equals 1 year back in time. 10 light years equals 10 years into the past. 1 billion light years equals 1 billion years ago. Distance is time. Time is distance. They're inseparable. And this means something profound, something that should change how you see everything. You can never see anything as it is, only as it was. Even the person sitting across from you at dinner, the light bouncing off their face takes a tiny fraction of a second to reach your eyes. You're seeing them in the past, just a nanosecond ago, but still the past. Everything you see is history. Recent history for nearby things, ancient history for distant things, but always history, never the present. The present doesn't exist in any observable way. By the time light reaches your eyes, the moment it captured is already gone. You live in the past. We all do. It's just that, for most things, the past is so recent we don't notice. But in space, with distances measured in light years, the past becomes unavoidable, obvious, overwhelming. We're surrounded by ghosts, messages from things that might not exist anymore, light from sources that have moved on, changed, died. And all we can do is watch. We can never reach them, never visit them, never see them as they are now. We're observers of history, trapped in our moment, watching the past play out in light. Here's the paradox that should break everything you think you understand. Space is unimaginably empty and unimaginably full. At the same time, let me show you what I mean. Think about the space between stars. We talked about this earlier. Even at our fastest speeds, it would take thousands of years to reach the nearest star. The emptiness between stars is absolute. No air, no particles, no light from nearby sources, just void, pure, empty void, stretching for light years in every direction. If you placed 1 atom every cubic meter in the space between stars, you'd have more matter than actually exists there. The space between stars is emptier than any vacuum we can create on Earth, emptier than anything in your experience. It's not just empty, it's aggressively, overwhelmingly empty. Now think about atoms themselves. An atom is mostly empty space. The nucleus is tiny. The electrons are tiny. The space between them is vast. If you scaled an atom up so the nucleus was the size of a basketball in the center of a stadium, the electrons would be tiny specks orbiting outside the stadium, kilometers away. Everything in between? Empty. So imagine this. Space between stars is mostly empty, and the atoms that do exist in that space are themselves mostly empty. It's emptiness within emptiness, void within void. The universe is built out of nothing, separated by more nothing. And yet, point anywhere in the sky. Pick any direction, any random spot. Look deep enough, and you'll find galaxies, billions of them, each containing billions of stars. Each star potentially having planets, each planet potentially having moons. Space is empty, and space is full. Both things are true at the same time. How is this possible? Because distance changes everything. Because scale breaks intuition. Close up, space is empty. Atoms are separated by vast distances. Stars are separated by even vaster distances. Everything is isolated. Everything is alone in an ocean of nothing. But zoom out, pull back, look at the universe from a distance, and suddenly it's full. Galaxies everywhere, clusters of galaxies, superclusters, filaments and webs stretching across billions of light years. The universe has structure, it has pattern, it's organized. From far away, it looks full. From close up, it's empty. Both perspectives are correct. The universe is simultaneously the fullest and emptiest thing you can imagine. Now, let me tell you a story. The story of a single photon of light. Imagine a star, a massive star, much bigger than our Sunday. It's been burning for millions of years, fusing hydrogen into helium in its core, producing light and heat and energy, but it's running out of fuel. The hydrogen is gone. The star is dying. In its final moments, the star collapses. The core implodes, compressing matter to impossible densities. And then, in a violent burst, it explodes. A supernova, one of the brightest events in the universe. In that explosion, billions upon billions of photons are released. Light in every direction. One of those photons heads in a particular direction, toward where Earth will someday be. Except Earth doesn't exist yet. The Sun doesn't exist yet. This is billions of years ago. The universe is young. That photon begins its journey. It's moving at light speed, 300,000 kilometers per second, the fastest speed possible, and it's heading into the void. For a while, there's light around it. Other photons from the same supernova, spreading out in every direction, but space is expanding. The photons spread apart. After a few years, our photon is alone, completely alone, surrounded by absolute darkness in every direction. It travels for 1,000 years, 10,000 years, 1,000,000 years. Nothing changes. It's moving at light speed through empty space, never slowing, never stopping. There's nothing to slow it down, no air resistance, no friction. Just darkness and emptiness forever. It passes through regions where galaxies are forming. Young galaxies, filled with young stars, bright and blue and full of energy. But the photon doesn't stop. Light doesn't stop. Light only travels until it hits something. More time passes, 1,000,000,000 years. The galaxies it passed are older now. Stars have lived and died. New generations of stars have been born. But the photon is still traveling, still alone in the void. Finally, after traveling for billions of years, after crossing impossible distances, after spending more time in darkness than most stars spend existing, the photon approaches a small yellow star, an unremarkable star in an unremarkable galaxy. Around that star orbits a small blue planet. On that planet, life has evolved, complex life, intelligent life, humans. One night, a human looks up at the sky. The photon, after billions of years of travel, enters their eye. It hits a receptor in their retina. A chemical reaction occurs. An electrical signal travels to their brain. The human sees starlight. They see a faint point of light in the sky. They might make a wish, or they might just admire it for a moment before looking away. And that photon, which traveled for billions of years through emptiness, which crossed distances your brain cannot comprehend, which outlived stars and galaxies and entire epochs of cosmic history, that photon's journey ends. It's absorbed, its energy converts into a tiny electrical signal, and then it's gone. That's the story of light. That's what light years really mean. Every photon that reaches your eye has a story like this. A journey through darkness and emptiness, traveling for years or centuries or millennia, crossing distances so vast that your brain goes numb trying to imagine them, and all of it just to reach you, just to enter your eye, just to let you see. When you look at stars, you're not just seeing light, you're seeing the end of journeys. Ancient journeys. Journeys that started before you were born, sometimes before your species existed, sometimes before your planet existed, and there's something beautiful about that. Something profound. Space is empty, impossibly, overwhelmingly empty. Light travels through that emptiness for years, centuries, eons. Most light never hits anything. Most photons travel forever, or until the universe ends, whichever comes first. They're born in stars, released into the void, and they just keep going, forever, alone. But some light, a tiny, tiny fraction of all the light in the universe, some light finds an eye, a telescope, a receptor, something that can absorb it and convert it into information. And that's us. We're the something. In an ocean of nothing, separated by light years of emptiness, we exist, and light finds us. Ancient light, carrying messages from the past, telling us stories about where it came from and what it saw along the way. We're not separate from this emptiness. We're part of it, made from it. The atoms in your body were forged in stars that died billions of years ago. Those atoms traveled through space, through light years of emptiness, before ending up here. Before becoming you. You are made of star stuff. That's not poetic language. That's literal truth. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from stars. Stars that exploded long ago, scattering their atoms into space. Those atoms traveled. They crossed light years. They floated through the void for millions or billions of years. They gathered into clouds. Those clouds collapsed into new stars. Planets formed. Life appeared. And eventually, those atoms became you. You are the universe condensed into human form. You are light years of travel compressed into a body. You are emptiness that learned to think. And when you look up at the stars, when you see those distant points of light, you're seeing where you came from. You're seeing your ancestors, not biological ancestors, atomic ancestors, the stars that made the elements in your body. You're not looking at space. You're looking at home. The light years between here and there aren't a separation. They're a connection. They're the distance your atoms traveled to become you. They're proof that nothing in the universe is truly separate. Everything is connected by distance and time, and the slow spread of matter through the void. Space is empty, and space is full, and you are the proof of both. The calcium in your bones didn't come from Earth. It came from stars, massive stars that lived and died billions of years ago, light years away from here. When those stars exploded in supernovas, they scattered calcium atoms into space. Those atoms drifted through the void, traveling for millions of years, until they eventually became part of the cloud of gas and dust that formed our solar system. And eventually, they became part of Earth. And eventually, they became part of you. The iron in your blood has a similar story. Iron is only made in the most massive stars, and only in the final moments before they explode. Every atom of iron in your body was forged in the core of a dying star, then scattered across space in a supernova explosion. That iron traveled light years to get here, light years through emptiness and darkness, and now it's in you, carrying oxygen through your bloodstream. The oxygen you're breathing right now? Also from stars? Made in stellar furnaces, released into space when those stars died, eventually gathering into clouds that became solar systems, planets, atmospheres. You are made of immigrants, atomic immigrants from distant stars. Every atom in your body has a passport stamped with billions of years of travel. Your body is a collection of travelers from across the galaxy, all gathered together in one place, somehow organizing themselves into something that can think and feel and wonder about where they came from. You are not separate from the cosmos. You are the cosmos. You are a temporary arrangement of star stuff, a brief moment when atoms from across space organized themselves into a pattern complex enough to be aware of itself. Carl Sagan, the astronomer and science communicator, famously said we are made of star stuff. And he was right. But it goes deeper than that. We're not just made of star stuff, we're made of light years. The atoms in your body traveled cosmic distances to get here. They crossed the void. They spent eons floating through emptiness. They're still travelers, even now, even as they're part of you. And someday, those atoms will leave. When you die, when your body breaks down, those atoms will scatter again. They'll become part of the earth, the air, the water. They'll become part of other life forms. They'll continue traveling. Your atoms have been traveling for billions of years, and they'll keep traveling for billions more. You're just a stop along their journey. A temporary home, a brief moment when they got to be part of something aware. That should make you feel something. Maybe it makes you feel small, insignificant, like you don't matter. Just a temporary collection of atoms that will soon scatter and be forgotten. But here's another way to look at it. Those atoms, which have been traveling for billions of years, which have crossed light years of emptiness, which have been part of stars and planets and nebulas, right now, in this moment, they're part of you. They're organized into a pattern so complex that you can think about where they came from. You can wonder about the stars that made them. You can look up at the night sky and recognize your origins. You are the universe looking at itself. You are atoms that traveled from distant stars, organizing themselves into eyes and brains, looking back at those stars and understanding what they're seeing. That's not insignificant. That's remarkable. That's beautiful. The universe is vast. Light years of emptiness separate everything. And yet here you are, a collection of atoms that beat impossible odds to gather together in just the right way. In all that emptiness, in all that darkness, there's you, aware, thinking, feeling, looking up at the stars and understanding, even just a little bit, what you're seeing. Now think about this. Every person you've ever met is also made of star stuff, also made of atoms that traveled light years. Everyone you've ever known, everyone you've ever loved or argued with or passed on the street, they're all collections of ancient atoms that came from distant stars. We're all travelers, all immigrants from across space and time, all temporary arrangements of matter that will soon rearrange into something else. And in this brief moment, while we're all here, organized into these complex patterns, we get to experience the universe. We get to see it, feel it, try to understand it. That connection you feel with other people, it's real. And it's cosmic. You're made of the same stuff, literally the same kinds of atoms from the same kinds of sources. You're all part of the same story, the same journey from stars to here. The light years that separate everything in the universe, all that emptiness and isolation. It's not a barrier between you and the cosmos. It's proof that you're part of it. Your atoms had to travel those distances to get here, and in traveling, they became you. So when you feel small, when you feel insignificant looking up at the vastness of space, remember this. Those distant stars aren't foreign. They're not separate. They're your ancestors. The stars that made your atoms, and you carry them with you, in every cell, in every breath. You're not small. You're ancient. You're billions of years old. Your atoms are older than Earth, older than the Sun, older than the solar system. They've seen things you can't imagine. They've been part of stellar explosions and nebulas and collapsing gas clouds. And now they're part of you. And when you look up at stars, when you see that ancient light that's been traveling for years or centuries, you're not seeing something distant and foreign. You're seeing relatives, other collections of atoms from similar sources, other arrangements of star stuff. You're all family, all of you. Every person on Earth, every living thing, all made from the same cosmic elements, all arranged differently, but fundamentally the same. The light years tried to separate everything, tried to keep everything isolated in an ocean of emptiness, but they failed, because matter travels, atoms scatter, and eventually, across all those distances, some of them gather together again. They become solar systems, planets, life, you. Distance doesn't separate you from the universe. It connects you. It's proof that you're part of something vast and ancient and beautiful. Every atom in your body is a traveler with a story, and all those stories led here, to you, to this moment, to you listening to this, thinking about light years and distance and time. You are made of light years, not metaphorically, literally. Your atoms traveled those distances, and now they're arranged into something that can understand what that means. That's not small. That's miraculous. Tonight, when you look up at stars, you'll see them differently, not as distant decorations, but as letters arriving from the past. Messages written in light, traveling for years or centuries or millennia just to reach your eye. You're receiving mail from senders who died waiting for you to exist. Think about that. A star dies. It explodes, scatters light in every direction. That light travels through the void, through emptiness so complete your brain can't hold it. The light travels for 100 years, 1,000 years, 10,000 years, and finally, it reaches Earth. It reaches your eye. You see it. You see starlight, but that star? Long gone. It exploded before your grandparents were born. maybe before humans existed, maybe before Earth existed. But its light kept traveling, kept moving through the darkness. And finally, after all that time, it found you. Every point of light in the night sky is a message like this, an ancient message, a story told in photons, and you're the recipient. You're standing on a small planet, orbiting an unremarkable star in an ordinary spiral galaxy. In a universe so vast that light years are barely adequate to describe it, you're surrounded by distances your brain cannot comprehend, by emptiness so complete it defies description, by timescales so long that your entire species is just a blink. And yet, here you are, made of atoms that traveled those distances, looking up at light that crossed those voids, understanding, at least a little bit, what you're seeing. That's the paradox we've been building toward, the resolution we've been moving toward. You are impossibly small, and you are infinitely connected. Space tried to separate everything. Light years of emptiness between stars, billions of light years between galaxies, distances so vast that nothing should ever touch anything else. Everything should be alone, isolated, lost in the dark. But you're not alone. You're made of atoms from distant stars. You're connected to everything by chains of cause and effect, stretching back billions of years and across billions of light years. Your atoms are travelers. Your body is a meeting place for matter from across the galaxy, and you can look up at the stars and recognize what you're seeing. You can understand, at least partially, the distances involved, the timescales, the emptiness, and in understanding, you become part of it. We are islands of light in an ocean of darkness, someone once said, too far apart to ever meet, able only to see each other's ancient glow. And that's true. In a sense, we are isolated, separated by distances we can never cross. Even at light speed, the journey between stars takes years. The journey between galaxies takes millions or billions of years. We can see each other, but we can never touch. But here's what that person missed. We're not separate islands. We're the same island. We're all made from the same ocean. The same atoms, recycled over and over, flowing through the universe like water through a river. You're not separate from the stars. You're part of them. They're part of you. The distance doesn't separate you from the universe. It defines you. It's proof that you're connected to everything. Your atoms had to cross those distances to become you. Light has to cross those distances to reach your eyes. Everything is traveling. Everything is moving. Everything is connected by journeys across space and time. Light years are not barriers. They're connections. They're threads linking everything to everything else. And you're woven into that fabric. So yes, you're small. Impossibly, incomprehensibly small compared to the scale of the universe. You're a collection of atoms on a tiny planet orbiting a medium star in an ordinary galaxy in a universe containing hundreds of billions of galaxies, each with hundreds of billions of stars. You're nothing. A blip. A brief spark of awareness in an ocean of darkness and emptiness. And yet, you matter. You're here. You exist. You're aware. And in being aware, you give the universe a way to see itself, to know itself. Without you, without conscious beings to observe and understand, the universe would just be matter and energy following physical laws. Atoms moving through space, light traveling through darkness, all of it meaningless, all of it without purpose or direction. But you're here, and you can look up. The universe spent 13.8 billion years and 93 billion light-years of space, arranging itself in such a way that it could become aware of itself. And you're part of that. You're one of the places where the universe became conscious. That's not small. That's profound. So when you feel insignificant, when the vastness of space makes you feel like you don't matter, remember this. The universe made you, not randomly, not by accident, but by following the laws of physics across billions of years and billions of light years of space. Gravity pulled matter together. Stars formed. Stars died. Atoms scattered. Planets formed. Life appeared. You appeared. All of that, all of those processes led here, to you, to this moment. The universe wanted to know itself, and you're the answer. Close your eyes now. Feel the atoms in your body. They've traveled light years to be here. They've been part of stars and nebulas and comets and planets. They've seen things you can't imagine. They're older than Earth, older than the sun, older than anything you can see or touch. And right now, they're you. They're organized into a pattern called your name, a pattern that can think and feel and wonder. Breathe in, that's oxygen from stars. Breathe out, that's carbon from stars. You're literally breathing star stuff. You're made of the universe. You're not separate from it. You're not on it or in it. You are it. Tomorrow, when you wake, you'll still be traveling through space. Earth is orbiting the sun at 30 kilometers per second. The sun is orbiting the galactic center at over 200 kilometers per second. The galaxy is moving through space at hundreds of kilometers per second. You're never standing still. You're always moving, always traveling through the cosmos. Just like your atoms have always been traveling, just like light has always been traveling. Everything moves. Everything travels. Everything is on a journey. And for a brief moment, a cosmic instant, your journey is happening here, on this planet, in this galaxy, in this time. Make it count. Not because the universe demands it, but because you can. Because you're here. Because you're aware. The light years tried to keep everything separate, tried to make everything alone, but they failed. Because light travels, matter travels, and eventually, across all those distances, things connect. You're proof of that. You're a connection point, a place where matter from across the galaxy gathered together and became aware. That's not insignificance. That's beauty. That's meaning in the face of emptiness. That's light in an ocean of darkness. Sleep well, knowing you're made of ancient light. The atoms in your body once traveled distances your mind cannot hold. They crossed light years to become you. They've been on a journey for billions of years. And right now, that journey is here, with you. Tomorrow, the journey continues. The universe keeps expanding. Light keeps traveling. Atoms keep moving. And you'll wake up, still made of star stuff, still connected to everything, still part of this vast and ancient and beautiful cosmos. The light years tried to break your brain, tried to show you how small you are, how vast space is, how impossible distances become when we measure in years of light travel. And they succeeded. You do feel small now. You should. You are small. But you also know something else now. Something deeper. Something more true. You're small, but you're connected. You're made of light years, and that makes you part of everything. Sleep now. Let the distances fade. Let the numbers blur. Let the vastness wash over you like a wave. You're safe here, on this small planet, in this moment, made of star stuff, surrounded by ancient light. You belong to the cosmos, and the cosmos belongs to you.